Hello friends, in this problem there are two concentric shells, capital I and 2R, having charges QA and QB, and the initial potentials are given to us. Now it is given that the shell B is Earth. Now final charges on A and B are given to us QA and QB prime. So we have to identify the correct options. So let us again draw this diagram. So we have two shells. As per the diagram, we have two shells. Let us redraw this once again. Okay, so we have two shells. The first shell, that is the innermost shell, is having radius r and initial charge QA, while the outermost shell has radius 2r and charge QB. This is the initial charge, right? And it is also given that the potential of these two shells are 2v and 3v by 2. So let us call these points as points A and point B. We know that potential of point A can be written as kqa by r plus kqb by 2r. And this potential is given to us in the problem as 2v. Let us call this as equation 1. Similarly, for point B, we can write the net potential of point B due to both the spheres will be equal to kqa by 2r plus kqb by 2r, which is given to us as 3v by 2. Now from these two equations, we can actually solve for the values of qa as well as qb, but also from these two equations, I can find the ratio of qa by qb, which comes out to be equal to 1 by 2, which matches with our option A. Now further, after earthing, it is given that now the outermost shell is connected to earth. So let us now connect the outermost shell to earth. There will be no change in charge of the inner sphere since it is isolated. Now I am assuming the charge on the outer sphere is QB prime. So the potential of point B can now be written as KQA plus QB prime divided by 2R, which should be equal to 0. That is QB prime should be equal to minus QA. Further, potential of point lying on the first sphere can be written as KQA by R plus KQB by 2R, where QA prime, sorry, I should write it as QA prime and QB prime, where QA prime is equal to QA and QB prime is equal to minus QA. So from this, all these three equations that we have already generated, we can finally find VA minus VB, which comes out to be equal to V by 2, and this matches with our option D. This is our final desired result. So there are two correct options for this problem, option A as well as option D. Thank you.